Lastly, let's talk about the fundamental identity. Recall the picture from the last video where we defined sine and cosine of this angle t to be the y and x coordinates of this point. On this diagram, we'll notice that we've created a right triangle where the height of the right triangle is sine of t. This is our y coordinate. And the base of this right triangle is cosine of t. This is our x coordinate. Try this for yourself, but if we move that green point anywhere along the unit circle, you'll notice that we create a right triangle using the x-axis and a line parallel to the y-axis. Since we know both legs of our right triangle and the hypotenuse is always 1, the fundamental identity is just a special application of the Pythagorean theorem. Remember, the Pythagorean theorem says that a squared plus b squared equals c squared for any right triangle with legs a and b and the hypotenuse c. Since the x-coordinate of our triangle was just cosine of whatever our angle was, let's use alpha, and the y-coordinate of our triangle, the vertical leg, was sine of our angle alpha, we can imagine this becomes x squared plus y squared equals the length of the hypotenuse squared. But since this is a unit circle, the hypotenuse is always 1. Substituting sine and cosine into this equation as appropriate, we get our fundamental identity, sine squared of alpha plus cosine squared of alpha equals 1. And to be very clear, this means that sine of alpha squared plus cosine of alpha squared equals 1. This is called our fundamental identity because it is true no matter what angle is used, whether it's small, whether it's large, whether it's negative or positive, whether it's more than one rotation around the circle or not. Sine squared alpha plus cosine squared alpha always equals 1. We can use this in order to figure out new values of sine and cosine if we already know one of them. And in order to do that, we need to remember the 4 quadrants of the xy plane. In quadrant 1, y is positive and x is positive. That means sine is positive and cosine is positive. In quadrant 2, x is negative but y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive but y is negative. Take a second to remind yourselves where this means cosine is positive and where this means sine is positive. Let's say we know that sine of some angle is 5 over 13. We don't know the size of our angle. We just know that the y-coordinate of the terminal leg of our angle works out to 5 divided by 13. What we want to do is find cosine of that angle, which we can do without knowing what that angle is, as long as we know which quadrant it lies in. Let's imagine we've got our unit circle. We've got our initial leg, and we've got our terminal leg somewhere in quadrant 2. We don't know exactly where. It doesn't matter where. It could be a smaller angle or a larger angle, whatever we want. Somewhere in quadrant 2. Our angle, in this case, is alpha. And we don't know the exact size of alpha, but that's okay. We do know 2 things, though. We know that sine squared of alpha plus cosine squared of alpha equals 1. And we know that in quadrant 2, sine is positive and cosine is negative. Let's see if we can put all of this together to figure out what cosine of alpha is. Since sine of alpha is 5/13, that means sine squared alpha is 5/13 squared. 5/13 squared plus cosine of alpha squared equals 1. Since we're trying to find cosine alpha, we can treat this whole thing as a variable and solve for that variable. Specifically, we can subtract 5/13 squared from both sides, giving us cosine of alpha squared equals 1 minus 25 over 1/69. If we simplify that, that's the same thing as 169 over 169 minus 25 over 169. And that means that cosine of alpha squared equals 144 over 169. Now we don't want cosine of alpha squared, we want just cosine of alpha. And we've got to remember that anytime we take the square root of a variable, we've got to include a plus or minus. This tells us that cosine of alpha is plus or minus the square root of 144 over the square root of 169. The question is, which is it? It's not both. This is where we have to use our quadrants. We remember that we're in quadrant 2, and in quadrant 2, x, our cosine, is negative. That means that cosine alpha is in fact negative 12 over 13, which is a fact that we could calculate exactly, even though we don't even know the value of alpha. That's something that we'll talk about in future lessons. In class tomorrow, we will figure out more common values on the unit circle. We will talk about coterminal angles to find more values of sine and cosine, and then we will practice finding sine and cosine values of these new angles.